Right, I can see people joining the webinar. Welcome everyone. We'll give it another minute to make sure that we accept all the participants who want to attend the session. Yes, meanwhile, I can start sharing my screen. Okay, I think we can start the session. I hope most of the people interested are already in the webinar room, and if not, there's the first 5 minutes is just an introduction. So I hope people will join in as we kick off this session. But welcome everyone who's here. Nice to see many participants that are interested in our session today. We will discuss our approach to working with the rolling review of requirements and the application areas for essential ocean variables and essential climate variables. My name is Justyna Becker. I work at the Danish Meteorological Institute, and I'm a project manager for OBPS, which is the project inviting you today to this session. So just to start with a bit of introduction and background to both our project and this session, to provide a better and more streamlined ocean services and understanding of ocean health, there is a need to upgrade the space and surface-based observations and predictions, and to develop a solid network of regional and national actors to build ocean observing capabilities. We also need to successfully integrate these systems and ensure their interoperability. So many standards and best practices in ocean observations are being developed, which is great to see. And it is an important step to ensure this integration and interoperability of data. And processes like the rolling review of requirements, which we will discuss in more detail in this session, allow for compiling information about the requirements for observations and the observing system capabilities. That said, even well-established processes and standards can benefit from feedback and updating, and at the same time, they can be useful in development of other best practices in ocean observation. So relying on the rolling review of requirements approach, OBPS aims to deliver an improved standardized framework for sustainable ocean observation and to demonstrate how such integrated ocean observation system can function. We are an EU-funded project scheduled to run for 4 years from February this year to the early 2028. And we are 19 partners from 13 different countries, focusing on 6 different ocean climate application areas. More specifically, OBPS will use the rolling review of requirements approach to refine the current essential ocean variables and essential climate variables, and to develop new ocean indicators for sustainable development. We aim to develop these best practices and standards that can support both in situ and satellite ocean observing and create interoperable ocean data ecosystem that could support multidisciplinary needs. So our goal is to support regional and global climate assessments and projections, feeding also to Earth system modeling, which we will touch upon also in the session later today. If you'd like to learn more about our project, feel free to visit our website or find us on social media. We are both on LinkedIn and on YouTube under our project name OBPS. Meanwhile, today we will dive specifically into our approach with working with this rolling review of requirements approach and essential ocean variables and essential climate variables. We'll also give a specific example of how we work with a specific application area, which will be focused on sea ice. So we'll do that through 5 short presentations and a panel discussion. We will have Sabrina Speich from École Normale Supérieure introducing the rolling review of requirements, followed by Karina von Schuckmann from Mercator Ocean International, talking about the essential ocean variables and essential climate variables framework. Then we will have Gerard McCarthy from Maynooth University, following up on the definition of these EOV and ECV-based ocean climate indicators. Then we'll have Pia Inglust, my colleague from the Danish Meteorological Institute, giving an example of an application area on sea ice loss. And the presentations will close with Francois Cugnon from the Norwegian Nansen Center, talking about how we can improve Earth system models' performance with novel parameter estimation technique. And then after the presentations are done, we will have a panel discussions and a Q&A where we have the pleasure of discussing with Ronan McAdam from CMCC. We have Sourav Chatterjee from the National Center for Polar and Ocean Research from India. We have Stefan Olsen, who is the project coordinator of OBSI4CLIM, also from the Danish Meteorological Institute. And we will have Sabrina Speich from École Normale Supérieure also joining our panel. But without further ado, I will leave it to Sabrina to kick off with her first presentation.
Hello, good morning, everyone, and thank you for being here. My name is Sabrina Speich. I'm a physical oceanographer and one of the PI of OBSI4CLIM, and I have the privilege to be one of the chair of the Ocean Observation for Physics and Climate panel of the Global Ocean Observing System, which work closely with WMO in what is the rolling review requirement for the ocean applications. So today I will be providing a brief summary on the letter and how OBSI4CLIM European project will contribute to it. So the ocean play a crucial role in regulating weather, climate change, and extreme events. It absorbs 90% of the excess heat caused by greenhouse gases emission and sequesters around 1/4 of anthropogenic carbon annually. So the ocean it is warming, but is also becoming more acid and losing oxygen, all of which contribute to more frequent and severe ocean and weather extremes, such as rising sea level, marine heat waves, and hypoxic events. These phenomena are not only affecting marine ecosystem, but also coastal infrastructure and community. Until recently, the WMO rolling review of requirement process focused primarily on numerical weather prediction, where the ocean was seen largely in terms of sea surface temperature. However, the scientific community has now realized that the ocean plays a much larger role, even for numerical weather prediction, but not only, it is critical to account for the ocean full impact. This means we need continuous observation of essential ocean variables beyond sea surface temperature in order to improve prediction and address the broader climate challenges. To address these challenges, it is essential to develop a fit-for-purpose integrated ocean observing system. The system must provide actionable information tailored not just for climate monitoring, but for a range of societal drivers, including biodiversity, food security, and the livelihoods of billions of people who depend on the ocean. Combining observation with advanced numerical model will allow us to better understand and predict both ocean and climate change and extremes. So the rolling review requirements, that is known as the RRR process, is a systematic approach that supports the design and evolution of the WMO Integrated Global Observing System, that is known with its acronym WIGOS, which with a vision that extends to 2040. It involves gathering users' requirements for observation, evaluating the capabilities of existing observing system, and identifying gaps between needs and capabilities. By doing so, we can prioritize the most critical areas for improving and align them with the WMO broader goal. The key component of the WMO RRR process are several key components: long-term vision for global observing system, user requirement for observation, and implementation plan through member programs and agencies. It aims to ensure that the observing system we design today will remain relevant and effective in 2040 and beyond. And here is a kind of a cycle of the different discussion between the observing capabilities, user requirements, gap analysis, implementation plan, long-term visions, and program of member and agencies. So this is an example that I taken from the rolling review process. It is the Oscar page in WMO, and I put here the web link so you can look variable by variable what it is really. So it is divided by application areas. So here is the atmosphere, but you have also pages that are starting to be filled with ocean applications. Then we have the geophysical variable. Here we have the wind vector. And as you can see in the column, there are different precision about different numbers that are the horizontal, vertical, and temporal resolution. We have also the timeless, and so you see the different colors that have different meanings, the uncertainty and stability. So we have also the maximum, the goal, the best kind of resolution that we want to, for example, to reach, the breakthroughs, and the minimum, which is essentially a threshold. So the ocean application within WMO RRR framework has started to develop by identifying several critical application areas suggested by the GOOS and IOC community, such as ocean forecasting, real-time monitoring, coastal forecasting, and tsunami detection. And of course, these are the areas that are just the first cases to test the process, ensure that our observing system meet the diverse needs of global ocean users, from local communities to international climate services. However, we still lack an efficient tool to move from individual phenomena to an integrated observing system that captures the complexity of the ocean-atmosphere interface, for example. So OBSI for Climate, we are working to apply the WMO RRR process specifically to essential ocean variables and essential climate variables that will be explained by Karina following my presentation. This involves defining the process and identifying the needs to ensure that national observing programs such as EuroGOOS and EOS in Europe deliver coordinated input to global effort addressing climate-linked marine extremes. The goal is to transform the RRR approach into a functional framework for ocean observations. A sustainable, well-designed, and purpose-driven observing system is really critical for enabling both human society and ecosystem to adapt to climate change. And this is a request from UNFCCC. By improving data availability, and quality, we can make informed decisions, support the growth of sustainable blue economies, and better link observing enablers with end users. As of now, we are still operating with limited visibility, and it's time to turn on the headlights through collaborative global effort like GOOS. And here it is. Thank you.
Thank you so much, Sabrina. I think we'll take questions at the end of all the presentations. So now I'll invite Karina to share her screen. Thank you.
Thank you very much, and thank you, Sabrina, for transitioning smoothly to the presentation on informing about the concept and the framework of essential ocean variables and essential climate variables. And so I would like to start directly going into the theme. So what are essential ocean variables? So they have been implemented by the Global Ocean Observing System, part of UNESCO IOC, and are defined as to be able to deliver ocean forecasts and early warnings, climate projection and assessments, and protect ocean health and its benefits. And so they are identified as those as the vital signs in order to be measured. They help us to interpret the connection between the ocean and the elements such as the atmosphere, biosphere, hydrosphere, cryosphere, and anthroposphere in connection with the ocean. Also that the essential ocean variables are critical to allow the observing system to change and to develop around them as technology and also as capabilities evolve. And to focus on the essential ocean variables enables the ocean observations that cut across different observing platforms and offer the best, most cost-effective plan for providing an optimal global view for each of the essential ocean variables. At the same time, there is a similar framework available, which is part of the so-called Global Climate Observing System under WMO and co-funded by IOC, UNESCO, International Science Council, UN Environment. So the essential climate variables are here defined as a physical, chemical, or biological variable, or a group of linked variables that critically contribute to characterize the Earth's climate. So it's about a context incorporating the ocean. And currently there are 55 essential climate variables. And these variables provide empirical evidence needed to understand and predict the evolution of climate, to guide mitigation, adaptation measures, to assess risk and enable attribution of climate events to underlying causes. And also they are a very important tool, the essential ocean variables and the essential climate variables, to underpin climate services. And so they're required to support the work of UNFCCC and also the IPCC. So here's an overview on those variables which have been currently implemented in those two frameworks, the essential ocean variables and the essential climate variables. You can see for the ocean, they have been, as mentioned before, identified within 4 categories. So the physics, like the sea state, surface currents, salinity, etc. For the biogeochemistry, like oxygen, or nutrients, or carbon isotopes, etc. The biology and ecosystems, including, for example, phytoplanktons or seagrass. And also there is an identification of so-called cross-disciplinary essential ocean variables, which include, for example, ocean sound. For the essential climate variables, there is a distinction between the Earth system components, like for the atmosphere, for the cryosphere, the biosphere, the ocean, and the hydrosphere, so the water on land. And as you can see, and as you would expect with giving the component for the essential climate variables, that there's a majority of the ocean ones which are also integrated and overlap with the climate ones in the same manner. So how are these essential variables identified? So they're identified through specific requirements, and then negotiated with feasibility. So under the major objective that we cannot measure everything, but nor we do have to. So there are 2 major aspects of guiding this choice of the different prioritizations with these essential variables, from the impact to consider how the variable addresses the 3 GOOS or GCOS delivery areas, like climate forecasts and warnings, ocean health. So here's a specific example for the ocean, but it's similar also for the GCOS aspects, both from a scientific perspective and also for a service perspective. And as the second aspect of evaluation for the requirements is attached to the feasibility for sustained observations, which consider the measurements is technical, political, or economically realistic. And another aspect is important on the feasibility with respect to the cost effectiveness of including data generation and delivery into global data streams, leading to ocean information and leading also to specific products. and where you can see on the right-hand side the applied evaluation metrics, which will help to guide these different processes. So the goal is in order to, again, another information, in order to guide also the information, how the decisions are made in terms of the importance, and to identify the essential variables, there's specific goal to build the best observing system, integrating the different platforms to monitor and measure various phenomena, and also to identify with respect to societal requirements. So those classically has been developed for the physical variables, so I focus here with respect to the OBC for CLIM project on the physical variables under the EOV and ECV frameworks. So on the left-hand side, you can see independence of phenomena to societal requirements as a function of time and a function of space, which including the different processes of the ocean, like sea level change and also surface water, sea ice extent, coastal shelf exchange processes, etc. And which can be also then directly linked with the capacities today with respect to the observing platforms, hiding from remote sensing techniques to different types of in situ techniques, such as gliders or fixed aspects like tide gauges, etc. So these classifications and these different criteria help to guide the frameworks of the essential ocean and climate variables. So how they're further identified how this is done in practice. So they are identified by different experts panel based on the criteria I just mentioned above. So here again, you have examples for the essential ocean variables. And so when the essential variables identified, a series of recommendations are created and disseminated by the expert panels, including what measurements are to be made, what are the various observing options, and also the recommendation with respect to data management practices, all again guided across the relevance, feasibility, and effectiveness, as mentioned earlier, and with support of the identification of the processes, societal relevance, and our measurement capacities. An example, as already highlighted by Sabrina before, which she's sharing, and I'm a member of this panel, which is the Ocean Observations for Physics and Climate, the OBPS, and it has 3 parent bodies. So just to explain you a bit more, give you a bit more insight on the functioning of these different frameworks and how they are guided. So there's part of GOOS, GCOS, and the World Climate Research Program, and has to be contributed to the strategic objectives of these 3 programs. And here you can see that given that OBPS is stretching between both, it is also have a responsibility and courtesy with respect to the ocean relevant essential ocean and essential climate variables, as you can see here in this table, just to give you some numbers. So with this last slide, I just wanted to give you an additional wider context on where the essential climate variables, but also essential ocean variables are sitting. So on the right-hand side, you see this diagram, which is putting light on the essential ocean variables at the center, with providing insight into the overlaps or the different handshakes between the framework, like the essential climate variables I mentioned in detail, but there's also a framework of a so-called essential biodiversity variables supporting the biodiversity dialogue, international dialogue, and then the essential variables for weather, which are another aspect. And so you can see here this interface. And there are different application areas identified by GOOS, by the Global Ocean Observing System, with respect to climate, the Operation Ocean Services, and ocean health, with the respective international programs and initiatives touching the different spheres of the ocean, like the physics, biogeochemistry, and biology. Do not hesitate to ask any questions, and looking forward to the discussions. Thank you.
Thank you so much, Karina. Great insights into the EOVs and ECVs. And now we'll have that followed very smoothly by Gerard's presentation on the definition of EOV, ECVs based ocean climate indicators.
Thank you, everyone. And thank you, Karina and Sabrina, for a very nice introduction to this topic. So my name is Gerard McCarthy, and I work at Maynooth University in Ireland with Karina on the OBSI for CLIM, on this OBSI for CLIM project, looking at ocean climate indicators. So we've heard so far the rolling review of requirements and the essential ocean and essential climate variable definitions and their place in the ecosystem of data. The next step is to move on to indicators, the next step up the food chain, essentially. So this is a particularly timely exercise. We are in the middle of the UN Ocean Decade. The international dialogue can be framed here, so it's often framed as the Ocean and Climate Nexus, which is a convergence between the governance, the agreements and treaties, sustainable development and conventions. Within this data science and services sits many of the activities that us as scientists contribute to what is going on in terms of the ocean around data science and data services. This is particularly timely at the moment with the UN Ocean Decade. And around the UN Ocean Decade, there is another nexus essentially of other treaties, protocols, and initiatives that give real urgency to what we are doing in terms of working on these ocean climate essential variables and ocean indicators. So there's a unique opportunity to elevate the critical role of the ocean and to increase awareness of the unprecedented change that has been going on there. Now, we need to strengthen the evidence base on ocean knowledge and transfer the science and policy interface. And this is at a level essentially one step above from essential ocean variables. So we can look at the ecosystem of ocean data to ocean services here. In the center of this, we have the hierarchy going from raw data to essential ocean science knowledge and on again to products, all the way up into food chain through ocean monitoring indicators to the reporting agencies and finally the users. This is a full ecosystem based around the scientists that generate the knowledge at the base level, all the way through to societal and economic benefit at the far end of the user scale. The added value chain is at the core of the ocean and climate services that connect the raw data products and the blue knowledge to the high quality products and finally the indicators. To give a visual illustration of where we sit in that ecosystem when we're talking about ocean and climate indicators, we've heard from Karina about the essential ocean variables. Ocean indicators are the next level up, and they offer a more digestible and more understandable development of products from the essential ocean variables that have built upon the robust framework that we've heard from Sabrina as well in terms of the rolling review of requirements for delivering the most essential ocean observations. They're a step up in the sense that they are more digestible, and their intended audience is much wider than just simply to scientists. So the scientific community and the ocean climate services are faced with that challenge of uplifting our capacity from essential ocean variables to ocean indicators. Now, the benefits of ocean indicators are many on many fronts. So they facilitate the interface between science and policy. They assess the capabilities of the observing system in terms of delivering these high-level messages that are associated with ocean indicators. They can drive innovations, foster collaborations, guide priorities, strengthen communication, and interlink systems. In particular, even as highlighted by Justina at the introduction to this session, they form the backbone of scientific assessments. In particular, we can think about something such as the Intergovernmental Panel for Climate Change reports. Ocean indicators, climate indicators form the very heart of all of those. So without even showing you indicators, you could imagine the sort of things that can be delivered. So for example, here is ocean heat content. We've heard from Sabrina that almost 90% of the heat that's been trapped in the planet has gone into the ocean. And so ocean heat content is a distinctive indicator that allows communication of ongoing climate change to a very wide audience and is more digestible than the essential ocean variables that underpin it. So essentially, this is the challenge that, albeit that there's a wide range reaching use and applications, clear criteria and definition of ocean indicators are today lacking, and that is some of the work that we're currently doing within OBSI for CLIM and within the wider frameworks. There is currently no internationally agreed comprehensive set of ocean indicators to characterize ocean processes or a common framework with agreed methodology that would unite these individual efforts to create a common understanding and baselines that were required to monitor the changes in the ocean environment in a transparent and authoritative way. That is not the only challenge that we're faced in terms of dealing with ocean indicators. For example, as I highlighted the role of global climate indicators, global ocean indicators associated with international assessments such as the Intergovernmental Panel for Climate Change. Many governments are interested on a much smaller scale, and there's a huge challenge around the regionalization of ocean indicators. So once you move from a global scale to a more potentially societally relevant scale from the perspective of the many people who fund these ocean observations, there is a gap in terms of how you would go about that. So a framework that we're developing around the regionalization of ocean indicators is that we would have justified measures of ocean indicators, that they are measurable, including that they have capacity within the observing systems, that they are significant, and that we have a robust uncertainty framework associated with them, operational, so that they can continuously be updated at their scalability, and that they can be related and fill in even an explanation gap between the regionalized indicators and the global indicators that already exist, and that they are accessible, that they can fill that purpose of communicating to the broader audience beyond the scientific community or even within the scientific community. We can give an example of the types of challenges that we're faced. So on the western coast of Europe and Ireland, we have a situation where we have an unusual set of ocean heat content. So for example, this is, we previously showed how the ocean heat content globally is rising in line with ongoing climate change, which we all understand. However, when we get down to more local scales, there's quite a gap in terms of the scientific understanding. So Ireland, the terrestrial sphere, is the only country on the planet which has actually cooled since the 1940s, which is a reason because we've been downstream of the unusually cool Atlantic Ocean. So consistently developing these regionalized indicators presents a challenge that is not just technical, but also in terms of scientific explanation between what is happening on these global scales and on the local scales. So the ocean indicators are critical in terms of supporting the ocean knowledge transfer. If we take the ecosystem between the various panels, the Global Ocean Observing System, the ocean observations for physics and climate, we can see that there is a link to be made between those and the ocean indicators. So an ocean indicator refers to a measure that is based on a scientifically justified theory and verifiable data that informs on change in an ocean phenomenon. And the ocean indicator underpins our ocean and climate assessments relevant for informing policy and decision making. These, of course, need to be underpinned by criteria for ocean indicators that are justified, measurable, operational, scalable, accessible, and significant. So finally, in terms of implementing a set of pilot indicators across the 3 dimensions, physics, climate, biogeochemistry, and biodiversity, we're looking in this nexus essentially of physics and climate, and in particular within the OBPS for CLIM project, we're focused on that physics and climate section, looking at ocean warming, sea level change, and sea ice change. And so I'll leave it at that as a brief introduction to ocean indicators.
Thank you so much, Gerard. Great. And now we'll have Pia giving an example of an application area where we work with a specific ocean indicators. So let me just share my screen. Here we go.
Great. Thanks a lot, Justina. Hello, everyone. My name is Pia Englist, and I also work at the DMI. I work in the Satellites and Arctic unit. And the presentation I will give today is based on the work from many colleagues at DMI, but also with input from the OBPS for CLIM partners. Sea ice is a key component of the climate system, playing a crucial role for air-sea interactions, the albedo, the ocean circulation, weather patterns, and so on. It greatly impacts the local environment. Both the animals and the local communities closely rely on the sea ice in terms of getting around, hunting, and on the sea ice to protect the coastline from winter storms. The presence or absence of sea ice also directly affects shipping routes and the opportunities for resource extractions. Last but not least, observed changes in the sea ice provide one of the clear signs of climate change, and the reduction in sea ice leads to accelerated warming, which is one of the main reasons we see an Arctic amplification in the warming rate. So this makes the sea ice both a key indicator and a key driver of climate change, and it's therefore crucial to accurately and continuously monitor the sea ice. Next, please. GCAS has defined a set of 7 geophysical variables, the sea ice ECVs, that are critical to monitor in this regards. And these are listed here. It's the sea ice concentration, the sea ice thickness, snow depth, albedo, ice surface temperature, sea ice age, and the drift. And this table, which is from a paper from Thomas Laverne, in 2020, it provides a brief descriptions on the ECVs themselves and the factors determining them and what they are relevant for impacting. And from this, I believe it is clear that for sea ice, there are several key variables with the potential to become climate indicators of sea ice loss. And on the next slide, I have listed a lot of these potential sea ice climate indicators that we have discussed within OBC for CLIM. And our task is now to identify the most relevant indicators to be used to assess and to monitor the global and regional trends of sea ice loss. And this should, of course, be done by considering the criteria for indicators that Gerard just presented. Today, the most commonly used sea ice indicator for sea ice is the sea ice extent, which is defined as the area where the sea ice concentration is greater than 15%. And I'm sure that you're all aware of these or similar figures that show the last decline in sea ice extent over the past 40 years or so, with the most rapid decline during summer and a tendency of the monthly extreme low sea ice extents to fall in the second half of the record, as you can see from the figure to the right. But there are also alternative indicators that can be derived from the sea ice extent. And on the next slide, you can see an example of this. That could be the trends in the sea ice freeze up and in the breakup dates. So the freeze up date is defined as the date when the sea ice concentration climbs from below to above 30% and remains so for at least 5 days. And the opposite is the case for the breakup date. And from these figures, it is clear that the freeze-up date is now occurring later in the season, while the breakup date is occurring early in the season, with some regional differences that are important for both shipping and the local communities. So when you know both the freeze-up date and the breakup date, it's easy to calculate the number of days with open water, and that is shown on the next slide. Where you can see the average number of open water days per year for the period from 1979 up to 2021. And a potential indicator of sea ice loss could therefore also be the trend in open water days as illustrated to the right. And as you can see from the figure, the Arctic is generally experiencing more and more open water days, up to a month more per decade in some regions, for example, the northeastern Barents Sea. And that means that there are some areas that were previously mapped as sea ice that are now shifted towards open oceans. And this also complicates the surface temperature monitoring of this region. Therefore, there has been some efforts now to combine 2 ECVs, namely the sea surface temperature and the sea ice surface temperatures, into a multi-ECV climate indicator, which can be used to consistently monitor the surface temperature of this region where the sea ice cover declines rapidly. The bar plot shows the trend in monthly anomalies of the combined sea and sea ice surface temperatures in the Arctic, with a total warming of about 4.5 degrees. And again, it does not warm the same everywhere. We notice a peak warming of up to 12 degrees in the northeastern Barents Sea, which corresponds to the region that also experienced the largest trend in open water days. Next slide, please. We believe that it's important to look into the relationships between the different ECVs and indicators, since this may bring new information to better understand and characterize the sea ice loss. And another example is shown here. So this shows the sea ice extent and associated ice surface temperatures, which are highly correlated. And for the early years, the hysteresis loop was rather predictable. But around 2007, you noticed a shift or a change in the loop. And that is also at the time where we have the largest loss of multi-year ice in the recent time. So this illustrates that by combining information from different ECVs or indicators, we might be able to better understand and predict the sea ice loss. So this was just a brief introduction to where we are starting from in OBC for CLIM. And this slide shows the next steps that we need to take from here. First, we'll assess the uncertainty of existing and selected ECVs. And this will be done by comparing the ECVs with in situ observations if they are there, and otherwise we will compare the ECVs derived from different sources, both including models and satellite data. And the next step will be to identify the most relevant sea ice indicators of sea ice loss, both regionally but also globally, because some indicators may be more important than others depending on the application or the region of interest. And next, we'll analyze the relationships between the different ECVs and indicators and try to come up with relevant multi-ECV indicators. And the derived indicators will again be compared both using observations and models. And finally, the requirements on the ECVs for adequate indicator derivation will be assessed and feedback on the requirements will be provided. That was all for me. Thank you.
Brilliant. Thank you so much, Pia. And then last but not least, we will finish our round of presentations with Francois's presentation.
Yeah, so thank you very much. So while the previous talk was explaining how much this ECV will be constructed or selected, now I will give an example of how they can be used in models. So yeah, so in that's just an aspect of it. There will be also activity where we'll use that for prediction or for improving climate prediction. So this one here, we have seen that we know that Earth system model that contribute to CMIP have some very large biases. And here's an example where we see the bias we have for the extent of the sea ice against biomass or ERA5, and we can see how the model in CMIP5 or CMIP6 have very similar bias compared to the observation. And another aspect of that is if we look at the sensitivity of the climate to CO2, so we see here the sea ice area on here, the global mean surface temperature with respect to CO2, we can see that the observed core is being located here, while all of the models are a bit out of this region. This clearly show that indicate that models now are either too warm or have the wrong ice sensitivity. So this raises the issue that maybe models are not parameterized correctly, and how we can make use of observation and ECV and EOV to better calibrate them to better project on the future. So there have been previous work done with data simulation method to calibrate model parameter. And this was work in 2014 where we showed that we could calibrate different sea ice parameter efficiently in EDA's work here, but also in a real framework. And what typically you're doing, you're perturbing different parameter on certain parameter, and we can use a match the misfits to the observation, putting that in the whole machinery of data simulation that can optimally use uncertainty of the model and the data, and you can identify the parameter likelihood that best perform with a wide range of observation. So this one was done in a forced ocean model. But when we are working with Earth system model, it's a whole different beast, because the bias are originating from different components, and they are transferred or amplified. So, and they are growing at different time scale. So what we have done, we are now working with fully Earth system model that are contributing to CMIP, and we are using data simulation to try to calibrate key parameter in the Earth system model. So here I'm showing an example that was developed for a EU project called TriAtlas, where we try to calibrate BGC ocean biogeochemistry parameter. And what we did here, that we have constrained the error in the ocean physics by doing state constraint on the, and we can see that this is globally average temperature, and we can see that how error is reducing. But when we do that, what we could clearly see that in the ocean biogeochemistry component, error was first strongly reduced, as you see with the integrated error, but then increasing again and over getting larger than without state constraint. So these clearly indicate that the current system that we have right now have been trained, or parameters have been calibrated to compensate for bias in the ocean physics. So what we have done in our system, we have using this iterative ensemble smoother, which is basically a data estimation parameter estimation method. And we have a long analysis where we constrain the error in the other components, and we use afterwards the performance of the analysis over a long period window to calibrate this parameter, and we can repeat that iteratively. And when we are doing that, we clearly see now that with the parameter estimation, which is the last one, we have a very strong decrease in error and performing stable performance. We also perform much better for parameters that have not been used for the parameter estimation calibration. If you want to know more, this paper can be accessible with a QR code. But now, that brings me to the conclusion. So we have seen that Earth system model parameter have very large bias, and that very often parameter of some component are calibrated to account for bias of the other components. So maybe it's not the most sustainable approach, because what you want ideally is to not account for the bias, and you want, if you improve the system afterward, that the whole system will get better. So now we have a new framework that can calibrate parameter based in an efficient and automated framework to calibrate parameter in Earth system model. And we want to apply a state constraint on the different components that are not related to the parameter, so that we can train those parameters in the bias-free configuration, but still in a coupled formulation. So in other words, with the EOV and ECV, we should be able to fully calibrate each of the components of the Earth system. And the parameters should be also directly applicable to other systems, not be depending on the bias of that particular model. So that's what we are trying to do in OBPS for CLIM. We'll be using the EOV and ECV, particularly related to sea ice, and we aim to reduce bias so that we can directly apply that and test them in the CMCC Earth system model. So that's just an example of how we can use that to enhance the skill of Earth system model. Thank you very much.
Brilliant. Thank you so much, Francois, for this presentation. And thank you so much to all the presenters for their wonderful insights. And thank you so much for being so on time with your presentations. We have accommodated a little bit of a buffer to in case someone went over time, but I see that was not necessary at all. But that means that we have more time for discussion and questions. If there are any questions from the audience, from the attendees, we of course welcome them. So if anybody would like to ask anything to the presentations that we have just seen, please go ahead. I think it works through the Q&A option here in Zoom. We have had one question so far that was regarding whether what happens if respective projects or institutions want to propose a new essential ocean variable. How does that process look like? I know that Sabrina, you've already addressed this question in writing, but maybe would you like to give a bit more light
Yes.
in plenary?
So naturally, this EUV need to be essential. So there will be a publication on essential ocean variables that Belen is leading, and I think she is in the webinar. But it is a really a community process. So these are experts that provide information through usually a publication of why this essential ocean variable, new essential ocean variable should be called and introduced in the ensemble. And then, of course, the expert panel reviews these proposals and make recommendations. So, for example, we have had a new essential ocean variables that was the bottom pressure. That was the process started in 2018, and if I'm not wrong, it was approved early 2024. But it's pretty long. It's not very short.
Thank you, Sabrina. Great. We'll wait for some questions to come up either in the Q&A option or in the chat. But meanwhile, I think we can turn to our panelists, and of course, everyone in the room, also from the presenters, are very welcome to contribute to this discussion. I think I would like to start with asking a general question to the panel of this work with the rolling review of requirements. And I'm particularly interested to understand what are the implications of using this approach, particularly for development of indicators or the modeling work that's being done. I think I can maybe start with Ronan, if you would like to address this question. But again, of course, if anyone would like to follow up, also go ahead.
Yes, very happy to take this one. Hello, everyone. Good afternoon, good morning. Great to be here. What can I say about indicators? Well, we've heard today that the RRI is kind of built from these two pillars of the of performing this technology requirement review, so the review of the requirements, what we need from observations, and this review of the current capabilities. And I think in my mind, how I visualize it is that this overlap where we are able to, observe some of the things we want to observe. And I think one of the outputs of that overlap would be an indicator, which is of course relevant, scientifically speaking, but also societally as well. So I think the RRR can direct us and should direct us really to more relevant and useful indicators. It's perhaps a justification, part of the justification of one indicator should exist and be used. I can very briefly give an example of some of the work we want to do in OBC4CLIM in this project, in particular looking at extreme events and marine heat waves. For example, a lot of work previously has been done using surface observation, satellite-based data of sea surface temperature. We're looking at marine heat waves at the surface because it's readily available. Moving towards subsurface marine heat waves brings with it certain challenges, the need to rely perhaps more on models or reanalysis or a more sparse observation network. And then at the same time, we're trying to deal with what aspects of marine heat waves are important for users and stakeholders, what depths, for example, might be more relevant for fisheries and aquacultures. And I think those are two kind of examples of what could be addressed in the RRR, and then sort of brought forward through this lens of marine heat waves.
Thank you, Ronan. Stefan, would you like to follow up?
Yeah, thank you. A comment to the previous question and to the answer here by Ronan. It's clear that the RRR process applies to kind of the established concept of EUVs, ECVs. But it's important to notice that ocean indicators is perhaps a less mature area of working, and where it's probably more dynamic, where we can develop new indicators, and where we in our project OBSE for Clean would of course also encourage you to get in contact if you have kind of unique ideas or want to kind of start a dialogue as a stakeholder on how to digest ECVs and UVs into new possible indicators, and how to potentially make them more relevant at a regional scale. So less rigid when it comes to indicators would be my point, and we of course have to work on the EUV ECV basis and consider the availability of data and the possible uncertainties, etc., as defined by the process.
Thank you, Stefan. Sabrina, you also have your hand up.
Yes, I want to complete maybe this discussions because so the rolling review requirements is essentially made for the requirement of society. So society want to know about extreme, want to know about the mean climate, want to know many things. But we cannot measure everything. We have cost that comes with it, and also capabilities in terms of technology. So we need a kind of find the balance to provide a quantitative question to the requirements, and also find the gaps in the observing system. And by chance, these kind of requirements are really also useful for modeling development, validation, calibration, etc., because they can see what are the requirements for observation, so they can also ask just that question from the observing system. But it is really a guidance to build an observing system that is fit for purpose, and it is difficult also to show is a message also to the space agency, to the national observing agency. What are the targets for them? Because otherwise there is no agreement, international agreement. So this is why it has been developed. And I think one of the most clear example is the implementation plan of the global climate observing system that provide such requirements already for climate monitoring. But we are still thinking about extremes, of course.
Thank you, Sabrina. I think we have a question here in the chat from Jay Perlman, which I think builds on what you just said, that the rolling review of requirements provides guidance to build an observing system that's fit for purpose, and that's based also on the user needs. So Jay is asking, how are the needs of marine industry built into the RRR? I don't know if you also want to address this aspect, or if there is anyone in the panel who would like to take that question.
I can take it if it is needed.
Yeah, go ahead.
So usually the rolling review requirements is made by essentially expert on different field, and the expert in the different panels. For example, if we take a goose for the ocean, it is they go out to the expert of different measuring systems. And this is how it is built. And of course, we do that using the technology that are available. And for space mission, for example, they have a 20 or 30 years kind of venture for the launching of satellites, and this gives the times of really in discussion. And for the in situ observing system, this can be really more quicker, and we really would like encourage the industry to discuss with the expert to make evolve this observing system capabilities much more quickly.
And another question, which again, I think the RRR process is quite interesting here to the audience. Another question is on how do we, which I imagine is general audience, how do we interact with the RRR process? What is that? How does that interaction work with?
So again, in the rolling review requirements for WMO for numerical weather prediction, these were the expert for this kind of application. Now we have the ocean application, and this is goes through GOOS and IOC in general for tsunami, for example. But of course, these are discussions that have just started, and for example, in terms of the project, the OBPS for CLIM is a clear example where we can provide elements, because we will be working in many different application areas that are not yet included in the rolling review for ocean applications, and this will be very important for GOOS itself and for the process WMO, and therefore we have started to really link the two communities, and this is why Belen is here, and she's saying something. So the definition of requirement for the essential climate variable are subject to public review every 5 to 6 years, and I mean the experts say what is needed, and then there is periodically a review for everyone to actively interact with this process, but also when we ask for expertise outside our just a small panel.
Thank you, Sabrina. Stefan?
Yeah, it's basically the same challenge that we have had when we designed our project OBPS for CLIM. How do we construct some good cases that can inform this process, not being an organization, but being a project? And for doing so, we defined these application areas, and we had a special focus on climate and global assessments, but still we defined some application areas that basically goes across a lot of interests. They include sea level, ocean transport, marine heat waves, the ocean mesoscale, stratification, and sea ice, as you have heard from Pia, for example. And by working with these application areas and seeing how we can address phenomena based on the existing data, and how we can build indicators that can inform society and various stakeholders, we hope to have a good case putting forward to the organizations and be part of this dialogue. But that's how we work, and we have been challenged also by the fact that physics and biochemistry and biology and ecology have been basically addressed by the funding agency, the EU Commission, that we work under in 3 different topics. So we will have basically a challenge also to work across these different spheres to make sure that the key messages and key observational requirements from each sphere goes into the same dialogue with defining the requirements. And in that, I would expect we also have a good dialogue with some marine industry actors like aquaculture and wind energy. But it's of course a challenging effort to reach everybody in that dialogue.
Thank you, Stefan. I see Jay has his hand up, but I have one question to follow up on this regarding this collaboration or working across the physics and biological and biogeochemical aspects. You say it's a challenge to work because of these silos or because of this, let's say, fragmentation, but is it also an opportunity, and what are the steps taken by OBSE4CLIM to address this challenge? Like, how specifically is this work bridged between these different elements?
Should I?
Yeah, that was a question to you.
I can give a start. Yeah, I mean,
yeah.
I'm again going back to the application areas. Marine heat waves, ocean mesoscale, they are physical phenomena, but they have a strong impact on biology, on cycling of chemical substances. So we have defined those basically to open the dialogue and not to dive into our own silo. And that is one way of working. But we also plan to establish a European UV ECV dialogue facilitated by the organization Eurogoose, which is organized under Goose, and bring together these active projects that work with this funding and actually have a lot of resources to put forward here to establish a dialogue between those and build a legacy in this structure after our project. But OBSE4CLIM has just started.
That's right. There's still time to address it. Okay, I would like to give an opportunity to Jay to follow up or ask the question they wanted. I see they lowered their hand. So Jay, if you'd like to contribute here, now is the time.
Thank you very much.
Yeah.
My question relates to best practices and standards, which is the topic of the workshop as a whole. And I was looking at the discussions that Pia gave on sea ice and was asking myself, what parts of the process she goes through can have best practices, and what type of best practices would you see in that?
I can start to answer, or you want Pia? Is Pia? Sorry.
Yeah.
Sabrina, if you have a good point, then
go ahead.
Yes. Yes. So the question is the best practices, the parts that we will incorporate for sea ice laws. Was that a good question?
I think the question was what are the best practices in the process of defining the indicator? So if I understood the question correctly, but yeah.
Yes. So I think Gerard, he showed the different criteria for the indicators, but I think in OBSE4CLIM, it's also a matter of the partners involved, what data they have, the time series that we have. That will be some of the components that we need to consider. And then, of course, when we do the work, we look at the uncertainties. If the uncertainties on the ECVs or the indicators are too large to tell anything on the trends, then that might not be a good indicator also. Yeah, and then again, as I said, different indicators may be important for different regions or different applications. So yeah, that is a last discussion, a good discussion that we need to have on that.
Absolutely. Thank you, Pia. Karina, you have your hand up.
Yes, I just want to complement what Pia said. So she replied to the question. I just wanted to add that there will be also in terms of best practices, but it is still, let's say, in under development of the Goose team on a so-called evaluation metrics as well. So in order to come to the deep critical wording on the best practices, which will be, I think, then another additional to what Pia said on the criteria and the different proposed, target, tailored, etc. For the best practices with respect to indicators.
Thank you, Karina. Sabrina?
So this is a question to Karina and Gerard and also Jay. So if we think about OBPS for CLIM, so our aim is, for example, to provide a guidance on rolling review of requirements, how to implement this approach in whatever observing system you are considering and the case. But the idea here is, as Goose is developing this framework, could we think by the end of the project to apply it to the OBPS for CLIM indicators and think about really to a paper in terms of best practices? Yeah, Kalina. Yes, I think there are many ways or pathways to do so. So where we have these discussions currently ongoing on focusing and having a specific cross-cutting activity on indicators and these indicator topics, and also all these aspects on the criteria and evaluation metrics is all new, so it needs to be applied. So that could be one pathway in terms of the demonstrating with specific pilots. It could be also another challenge, but which is a very important challenge, particularly when it comes to respect to tailored information for policymaking and other societal relevance. This is the regionalization aspect. So we need more regional information with respect to the indicators, and that could be another, let's say, very unique outcome also of OBPS for CLIM with respect to best practices, how to do this, what are the frameworks, what are the challenges, and how, with big recommendations, how we can proceed in the future to assure coherence. Because when you regionalize, there's also this enormous aspect of coherency between methods with the outcomes and values. So for one region to another, you want to assure that there will be a coherent approach, etc. So then the point of best practice is very essential in this regard as well. So in particular, when it comes then to bring out this, transfer this knowledge to non-experts. So this is a very sensible, and then best practices is a very important aspect where we could provide innovations with this project. But just some ideas, right?
And I'd just like to add, just to emphasize, I suppose what Karina said, but I think within the project we also have the opportunity areas in the areas that Stefan highlighted as well, looking at the particular demonstrator areas where we're going to essentially exchange between what we need from indicators and the developmental areas that we're kind of looking at. So there was almost a mini review of requirements within the project.
Thank you, Gerard. Ronan, do you also have a follow-up on this?
I have a follow-up to Jay's comment and question from earlier, just a brief one, about how the best practices are. He used Pia's example there. In that case, what best practices were involved, and I think to me that can be a part of the RRR itself, to when we're assessing the observations and the various data sets that are out there, to also report by various models of maturity of best practice, what level they are at, and what that might mean in terms of the RRR. So I think there's a great overlap between the two there, best practices and the RRR.
Absolutely. Thank you. Stefan, you had your hand up.
Yes, maybe. I mean, now I can perhaps just challenge Gerard and Karina. But what I hope to get out of the project is some clear examples of how to address uncertainties when going from global indicators to regional indicators, and also have a fairly objective approach to how to define ocean regions of relevance, and consider different phenomena as part of this regionalization. I think that's a kind of untouched territory, but I'm happy to hear comments from Gerard and Karina.
So I think regionalization challenge is a very kind of current one, and very kind of related as well back to, I suppose, maybe the more underpinning structures in terms of where funding nationally comes into these global observing systems, that each national agency and each national funding body tends to have a particularly regionalized focus. But I guess I see certainly the need for a robust and transparent framework, but also the need for a kind of a broader explanation, a kind of an explanation gap to be filled also. So say, for example, we could talk about a particular indicator such as ocean heat content, and potentially if you're in maybe trapped on a shelf sea somewhere, you maybe don't feel that ocean heat content is a relevant ocean climate indicator for you. Whereas in fact, I think, it's very important. We've already heard from Pia the long distance teleconnections between sea ice and many locations in the world. So regionalization is certainly a challenge, and a framework needs to be built around it. But I would also say, that we it needs to be, I suppose, not just clientelism as well, that we have to really kind of emphasize the broader scientific motivations of choosing kind of broader regions, rather than everybody wanting these indicators in their own backyard.
Karina? Yeah.
Thank you. And maybe also correct. So in addition to what Gerard said, I would even make it stronger. I think that, so thanks for raising this, but I would even state that the uncertainties are our only solution in order to get this regionalization challenge tackled with respect to the importance raised, such as currency aspects, methodologies, but also with respect to observing system recommendations. So having strong aspect to say that for some change in the ocean, we are not able, or within uncertainties, to provide a clear monitoring in a specific area of a specific ocean phenomenon, because the uncertainties are too large. This is a very strong observing system recommendation, which will be also a tailored one for policymaking and supporting developments. It's just one example. So, but I think the uncertainties are the key leveraging point in order to tackle this challenge.
Thank you, Karina. I think it's also interesting to discuss this link between ocean observation and the regionalization challenge and its relevance to policymaking. And here I would like to maybe ask a question to Suraf, who's also here with us and has some good insights on maybe how the rolling review of requirements approach could potentially benefit or influence policymaking and science planning for individual nations. Suraf, do you have a take on this?
I think this, thank you for this opportunity. So I think this has been discussed by Stephen and Karina as well. So yeah, I mean, the issues, the application areas of the global ocean climate issues we are tackling in OBPS for climate, although they are specific to European oceans or the Arctic oceans, those regional areas, but they have global footprints, as Gerard was mentioning. So even though the countries which are not involved directly in this project, but through OBPS for climate, we can give an example that how the national observation plans can be optimized, and maybe probably in the current scenario, the investment can be more targeted through scientific evidence that will come from our assessment of EOVs and their requirement review of their requirements, which is enabled by the approach, RRR approach. And also it helps the to get the best out of the national investments, because now also a lot of countries have their own long-term monitoring plans, but probably those are not following the best practices which we are talking about here. So it's not directly helping the GOES community or GCOS community. So probably if we can, through OBSI4Climate and using our approach, we can suggest a optimized framework and suggest them then how the individual national investment or observation plans can directly and more smoothly or efficiently contribute to the global climate monitoring. That's something I think it should come from the outputs of OBSI4Climate when we properly use the other approach on the EOVs.
Great,
Yeah.
thank you, sir. We also have one question here on the Q&A panel that hasn't been addressed yet, on whether there should be a separate portal on the rolling review of requirements to address the requirements of ocean-based of OBS and for research related to EOVs, ECVs. Surav, do you have any take on this?
Can you say the question, please?
There is a question on whether there should be a separate portal on rolling review of requirements to address the requirements of the OBS and for research related to the EOV, ECV. Is there something like a individual portal on the rolling review of requirements, or where is this information stored, I guess?
I don't have any idea if there is any existing one, but probably OBSI4Climate website will be the first one to be, where all the outcomes using the RRR approach on EOVs are like it's coming maybe in the next 3-4 years. All the outputs from OBSI4Climate will be providing something on that. But I'm not sure if anything currently existing there.
Perfect, thank you. I'm not aware either, but I'm also outside of the climate research community, so still relatively new to the OBSI4Clim and the ocean science.
I think we have Belen as part of the attendees.
Yeah.
Perhaps we can, if possible, upgrade her to panelist and exchange her views with us, if appropriate. I saw a hand raised earlier.
Yes, that would be great.
Can you repeat the name and I can put her as panelist?
Belen Martin.
Okay.
If that's okay, Belen.
Now it's too late. She's already here.
But yes, the idea of a more structured portal would be something to discuss how we can contribute as a project too, but it should definitely not live only as a project initiative, but
may in the meantime answer a comment that is in the chat from Raya. So the comment was the Southern Ocean Observing System is a major application component of the WMO RR, as the area needs to put up sufficient observing system in place. I suppose this is a question. And yeah, the polar region are actually both a focus where we need to extend the observing system, but of course in a rational way. And I might suggest that the Southern Ocean Observing System has never required a review from WCRP and from GOES. So maybe in order to evaluate what are the gaps, etc., they could ask these two programs to have a review going on.
Thank you, Sabrina. And we have Belen with us. Maybe she can address the question on the RRR portal.
Yes, many thanks for inviting me to participate in the discussion, because yeah, I had a couple of comments, and thank you also, Stefan, for calling me. So well, the first is that I'm super pleased, and maybe you are not so aware of that, but I'm very aware because I've been working with RRR and ECV for about 3-4 years now. So it's really great to see how you are putting together all these different frameworks that coexist, like ECVs, EOVs, indicators, observing best practices. And that in the framework of this project, you are really working with everything in a, well, I think that ultimately it will be really integrated. And so it's super, yeah, it's really a pleasure to see. And so I'm very happy that I can be witnessing this. And the second thing about the RRR, yeah, there is a portal. WMO has a portal for the meteorological application areas mostly, but there is some ocean. So there is a portal, I could put a link, where you can select the application area or the variable that you are interested in, and then you can see all the requirements, how, according to WMO groups of experts, GICOS included, what are the observational requirements, what you need to measure and how, what resolution, what uncertainty, etc., etc. So this is available. And for GICOS, so for the essential climate variables, there are documents, and you can also find them online, the tables of requirements on the GICOS website, basically. So yeah, I think this is all. Thanks again.
Thank you. Sabrina?
Yeah, I had the web link on one of my slides, so if the slides will be put together, so they can. Also, if you search as just rolling review of requirements, WMO, you find the page that Belen was saying.
Thank you, Sabrina. Yeah, I'm not sure about the slides themselves, but I know that the video of this session will be available on YouTube after this webinar. So it will be possible to once again go through the presentation. I think we're almost reaching the end of the session today. So I think maybe last question that I would have to, and it's an open question to all panelists and presenters here. Since we are hosted by the Ocean Best Practices System, do you have any thoughts or reflections on how OBPS can support the process of OBSI4CLIM working with the different best practices, and if there is a potential for interaction and collaboration here on developing best practices and standards that would emerge from the project? Stefan, would you like to?
I can say that we already plan and rely on the Ocean Best Practices system as the kind of permanent place to deliver our updates to the different protocols, if possible. Right now, I cannot say whether or not we rely on that system for the indicator work, but that would be on my wish list, at least, that can also go in that direction. But definitely it is the area where or the program we want to influence, and already this opportunity to join the workshop here and present our project is one step where, or at least a way where we benefit from the network.
Brilliant. That's great to hear. And maybe on that, unless there are other questions and comments, although I don't see any in the Q&A nor in the chat. So unless there is a last minute hand up in the air on Zoom, I think I will just thank all the presenters and all the panelists. Thank you for your time and effort to explain some of these efforts and approaches in OBSI4CLIM. I can maybe with a small bias say that it's a great project. So if anybody is interested in it beyond just these presentations that we've seen today, Please follow us on either our website or on LinkedIn. You can also get in contact with us directly. We always welcome dialogue and discussion on these issues. So yeah, I think I'll just say thank you for today and stay tuned for OBSE4CLIM updates. There's more to come.
Okay, can we stay on and put your screens on and I'll get a screenshot?
Of course,
Just
yeah.
Put your videos on.
We can. Thank you, Jay.
Oh, that's wonderful. Thank you very much.